Hello everyone, it is Crankshaft Day. We have got our work cut out for us today. So I've got the piston squirters in, and they're cinched up, Loctited in, so that's all done. Today's job is going to be to put the main bearings in, and we'll do a quick clearance check on the main bearings to make sure they're good. And I'll talk more about that in a little bit, but today I want to get that behemoth sitting in the block. This thing is very, very heavy, so I want to get this right the first time because I only want to have to lift it in and out one time. So when this thing's sitting down in the block, I want to go ahead and cinch it up and be done with it. So we'll go ahead and get started. I'm going to set the tripod up. I'll give you a bird's eye view of what's going on here, and I'll go through the steps that you need to do when you're installing a crankshaft. Here we go. So these are standard main bearings. I did not send this crankshaft out to get machined. It's standard. So standard on the bearings, rods and mains. And basically when installing these bearings, you just want to make sure that your journal surfaces are clear. Nothing in there that would get between the bearing and the block. Line up the tang on the bearing. Shove it into place. This is the thrust bearing. I'll go ahead and push this into place as well. Now there's a special procedure we got to do to align this thrust bearing, and I'll show that in just a little bit. But first I need to oil these surfaces before I drop the crankshaft down onto these bearings. I'm just using motor oil here. You can use something like Lubriplate. You can use some of the assembly lubes that are available that have graphite in them, but you definitely want to have something on them. Now normally if I was doing just about any other engine, I would set the crankshaft down in there dry, and I would take a clearance measurement with a Plastigauge, and then I would lift it back out, oil the surfaces, and put it back in place. But since this crankshaft is so heavy, I'm going to oil these upper bearing halves before I set the crank into place, so I don't hopefully have to lift this thing out again. And I also have to be aware that I have to line up my marks on the camshaft and the crankshaft 6 and 12, so I'll do that as I'm guiding it in. And here we go. Hopefully I don't get a hernia doing this. Or pinch a finger. Okay, marks are lined up. That's where she sits. Now, I'm going to do a Plastigauge check. And Plastigauge is just a method of verifying that you didn't screw up, or the machine shop didn't screw up, or the company that manufactured your bearings didn't screw up. So it's just a method of verifying everything before you bolt everything together. So it's not a substitute for calipers. So our clearance measurements for this crankshaft need to be somewhere between 18 and 46 ten-thousandths of an inch. So 1.8 thousandths to 4.6 thousandths. I expect it to be quite a bit tighter than 4.6 thousandths. That's the maximum tolerable amount for this engine, and that's quite a bit, so it will be less than that. I'm guessing somewhere around 20 to 25, 10,000, somewhere in that neighborhood. But we'll find out in just a little bit. So I did measure this crankshaft with calipers before I took it out, and if you do that, you need a caliper that can measure 10,000ths of an inch, something like this. And they call these vernier calipers, and you get that 10,000ths measurement by these little hash marks. So you take your measurement here, and then you flip it over and see which one of these lines up. That's your last digit, which is 4 decimal places to the right of your whole number period. So I did measure this crank when I took it out, and it measured out fine. That's the reason I didn't send it out. But we still have to double check and make sure that the bearings are correct and they're going to have the correct clearance. So we'll go ahead and do that now. And the method we use is just Plastigauge. So this Plastigauge is measuring between 1 and 3,000ths, which should be okay for our application. And it's a very simple thing to do. You just tear off a piece and we open it up. Easier said than done with gloves on. And inside we have this little wax strip. We're just going to lay that across our journal that we want to measure, missing the oil hole. And I'm going to do that to all of them. And then we just set our caps in place and we run the bolts down. So I'll pop the bearing in the cap. And we'll set it in place. Number 1, facing forward. I'm only going to use 2 bolts, because all I'm doing is taking a measurement here. What I'm doing in this situation basically applies to any engine. So yeah, this is a diesel, but this method of measuring clearances works for just about any engine. Number 3 is the thrust bearing. You can see these machine cutouts for the bearing. As I mentioned earlier, you're just verifying that there weren't any major mistakes made when ordering parts, when machining the crankshaft, although I didn't machine this one. But you just never know. These bearings are stamped standard, but what if they're actually a 10 over bearing? And they were just stamped wrong. So I did not lubricate these bearing halves because I have to take them back apart anyway. Alright, I'm just going to run this down with an impact real quick. When you're doing the quick and dirty method with an impact like this, you just want to make sure you don't exceed the torque of the main cap bolt spec, which in this case is 95 foot-pounds. My gun is all the way off. There's no way that it's going to achieve 95 foot-pounds like that. So now I just have to take all the bolts back out. Grab a dead blow hammer. Dead blow is not going to work. Get something with a little bit more oomph. We'll set these aside. And there we go. Let's see if I can zoom in on one journal here. So now, after we have tightened our caps on the Plastigauge, we're just measuring the thickness of that little wax string. And the thickness corresponds to a clearance. So we just match up the thickness with the right size and then gives us the number we need. So that one looks to be right at 3 thousandths. And that one is the same. This one's a little bit less. And that one's 3 thousandths. And that one's a little bit less. So we're within our target of less than 46 ten-thousandths of an inch, or 4.6 thousandths of an inch. And that's how you use Plastigauge. It's just a quick and dirty method to make sure your clearances are reasonably close. But you can find excessive clearances that way. You can find clearances that are too tight. You can find a journal that's not ground properly side to side, because one side will be thicker than the other. It won't find an egg-shaped crank. I've had that problem in the past, where if the journal is ground egg-shaped, it just depends where the journal lands that you get a clearance measurement that might be or might not be correct, so it won't find that. But it is a quick and dirty method for just verifying clearances before you cinch everything up. So we're okay here. I'm going to go ahead and just scrape this off with my fingernail. It's just wax, it won't hurt anything. Now I can bolt the main caps on for the last time and adjust our throwout bearing, or thrust bearing, thrust bearing, adjust our thrust bearing. Now I can put all 4 bolts in, but before I do that I need to give them a good coating of oil. If when you're running these down by hand, if it feels tight, you need to make sure there's no liquid down in a blind hole, or the threads might be compromised by contaminants. Somewhere in here is the stud for the oil pump pickup. I'm going to throw it right here for now. I may have to move it if I'm wrong. These caps are all numbered, so you can't really mess up here. So 1, 2, 3, 4, 5, and they all have arrows facing towards the front of the block. Now I'm just going to run them all down. Starting in the middle and working my way out. And then I'm going to loosen the center. This is where our thrust bearing lives. And this is just something you're supposed to do to anything with a thrust bearing. So the bolts are loose, so this thing is free to move around a little bit. And what we want to do is we want to run the crankshaft back and then forward. So back and then forward. And while we're holding forward tension on the crankshaft, then you tighten up those bolts. And the reason we do that is because typical crankshaft thrust is in the forward direction. When there's a clutch on here and you're standing on the clutch pedal, the force is forward. Same thing with the automatic with the torque converter, the fluid pressure is forward. So you just want to shove that bearing forward so that the end play of the crankshaft is correct. And if I can, I'll check that in a little bit. But now we're going to torque it. Torque spec for this crankshaft, every engine is different. This one, they want you to torque all the bolts to 75 foot-pounds and then go around and torque them all to 95 foot-pounds. Once again, I start in the center. and work my way out. After we get them all torqued to 75, my gun goes up to 95. And we do it again. There is probably some sort of a specific sequence to tighten these, but most engines just start in the middle and work their way out. Go over those one more time. And we're done. And with that, we should be ready for pistons. So the next step will be to install the piston rings on the pistons. And from there we'll start installing pistons and rod assemblies into the block. Should be the next video we see. I can go ahead and put a dial indicator on this and check the end play real quick. Okay, I recommended end play is supposed to be somewhere between 2 and 9 thousandths. I've got the crankshaft shoved all the way back. Now I'm going to shove it all the way forward. That's 8 thousandths. Let me check it again. 8 thousandths. We'll take it. Thanks for watching.